In this example of solving trig equations, we're going to be involving kind of half or double angles in this problem. We're going to do two different answers to this one. We're going to be doing answers that are limited between 0 and 2 pi, and then answers that are not limited at all. So, first thing is, and I have this information again over here just because these problems have a tendency to be non-calculator. Not all of them, but they have a tendency to be non-calculator, and so answers are going to be coming from our 30, 60, 90s, 45, 45, 90s, or just a point on one of the axes. And then I need to know my quadrants, positives and negatives. So, first thing I see is they don't match. That 2 messes with it. I'm going to be subbing this out now. In the past, that 2 would have messed with our period. However, we're about to replace it. So we're going to treat it as a trig identity, and we're going to get rid of that piece. So cosine of 2x is equal to 2 cosine squared x minus 1. So this whole piece is going to get replaced with this. So we got 2 cosine squared x minus 1. So I just used a trig identity to replace this, so that way I just have cosine x's, not cosine 2x. And then this very much has a quadratic feel to it, so I'm going to bring the cosine x over. 2 cosine squared x minus cosine x minus 1 equals 0. So this, if it helps to kind of write this out, some people will see it, some people won't. So if you don't see it, I would take that quadratic and write it out like 2x squared minus x minus 1. So that's 2x squared minus x minus 1. And try to factor it this way. So my only choices here would be a 2x and an x. I'd have to have a 1 and a 1. And then when I multiply the outsides and the insides, I get a 2x and a 1x, and they need to add up to a negative. So I need that to be a negative 2x and this to be a positive 2x. So on our problem, 2x plus 1 is 2 cosine x plus 1. And this is going to be cosine x minus 1. All right, what do we naturally do with all of our factors? We set them equal to 0 and solve. So 2 cosine x plus 1 equals 0. Cosine x minus 1 equals 0. So I'm going to subtract 1 and divide by 2. So cosine x equals a negative 1 divided by 2. And here we're going to have a cosine x equaling a positive 1. All right, so triangle that has a 1 and a 2 in it, that's going to be our 30, 60, 90. So cosine of 60 is going to be a 1 over 2. We got talking about a 60-degree reference angle, and we need cosine to be negative, which are these two quadrants. So we're looking at a 60-degree reference angle here and a 60-degree reference angle there. So if that's 60, that is a 120. And this is a 60 past 180, which is a 240. So our angles are going to be a bunch of pi over 3's because they're 60s. And so that one is 2 pi over 3. And this is going to be 4 pi over 3. All right, so there's 2 of our answers, and then we'll see what this one gives us. Cosine of some angle is going to equal 1. Well, that's not a triangle, so it's going to be a point on here, and cosine is an x value, so we're looking at 0 degrees. So x is going to equal, I guess, 0 radians. Okay, so that's part A of when we're locked between 0 and 2 pi. If we're going to do an infinite amount of these things, our period, because we subbed this out, is still going to be 2 pi. So we take all of our answers and account for the fact that we would have these coterminal angles off of that. So we have 2 pi over 3 plus 2 pi n. So an infinite amount of these coterminal 2 pi's. 4 pi over 3 plus our period times however many amount of them. And then just 2 pi n. We don't need to add 0 to it. Now the thing is, on all of these, it's where n is an integer. All right, we have to make sure that n is a whole number. Positive or negative doesn't matter because it just depends on which way you want to do your coterminal angle. But that is your B answer, where we don't have a restriction on our solutions. All right, and then we got one more. So this one is a little rough looking. So we have 3 cosecant squared of x over 2 is equal to 2 secant x. So cosecant squared and secant, I don't love those at all. So I'm going to rewrite those first thing as sines and cosines. So I'm going to take the reciprocal of this, which really means I'm just going to pull it down to the bottom. The 3 is not attached to that, so it's going to be 3 over sine squared of x over 2 equals 2 over cosine. Now that didn't seem to make anything easier. However, I can get it out of the fraction just by cross multiplying. So if I do 2 sine squared x over 2, so I cross multiply, and that's going to equal this cross product equals that. Okay, so seems we're in a weird spot. Sine squared, we could replace it, except it has this x over 2. So because it's an x over 2, you actually have a trig identity to that. So sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Now I don't see how that's going to be any easier by replacing that with something that has a square root. However, it has a square on it. So we're really going to have 2 times this plus minus square root of this, which doesn't look like we're going to be able to do much with it. However, 2 good things are about to happen. One is we are going to square root a square. Right? So the square is going to square root this, it's going to cancel this, and it's actually even going to get rid of the plus and minus because you're going to square the positive or the negative and still get positives out of it. And you're going to have everything in terms of a cosine. So no longer you have sines mixed with it or cosecants or any of that sort of stuff. So it actually cleans itself up really, really nice. So here this whole thing goes away. 1 minus cosine x over 2. Even better, it was being multiplied by 2. I lost a 3 on my cross product here. Okay. So that 2 is going to cancel that 2. So it cleaned up actually very nice. All right. So I'm feeling like we want to put everything over to one side. So I'm going to bump the cosine over to here. So we're going to add a cosine over to this, and that's going to make it a 4 cosine, equaling the 1 by itself. Divide by 4, divide by 4, 1/4 equals cosine x. Bad news. Bad news is we don't have a triangle that has an opposite and an adjacent equaling, or an adjacent and a hypotenuse with 1s and 4s. So it's not going to be an exact answer. It is going to be a calculator problem. So we basically just do the inverse cosine of this. So we'll be typing this into the calculator, and that is going to spit out an answer of 1.32. All right, so here's the trickiness to this. It goes back to this type of problem. When over here we had cosine of a negative value, we were left in these two quadrants, where this time we have cosine of a positive value. So that means our answer is going to come from those two quadrants. So this radian value is 1.32, but so is that, 1.32. So, normally if we have it in degrees, we'd be taking 360 minus whatever that angle is, but this is 2 pi. Well, the decimal version of 2 pi is 6.28, so we're going to take 6.28 and we're going to subtract 1.32 and get 4.96 for that value. So it's the same concept, just a little bit less often, less common, but it's still taking, if we want to figure this angle out, if that angle was 20 or 30, if that angle was 30, we would take 360 minus the 30 and get 330. Instead, we're taking that as 2 pi, also 6.28, and subtracting the 1.32. So that's part A, where you're locked into 0 to 2 pi. Part B is really not that much different. It's 1.32, and our period did not get messed with at all. We had no 2 theta mixed into this, and because we took and subbed that out, we don't have any adjustments to the period. So 2 pi n and 4.96 plus 2 pi n, where n is an integer. Okay, and that covers a little bit more challenging double and half angles, solving equation types of problems. Thanks.